Hello everyone, in this Thierry Sicard tutorial number 39, we will talk about the periodic element table, called also Mendeleev table. We will be more focused on the column 4, where are located carbon, silicon and germanium, and the neighbor right and left column used for doping the element of the fourth column. Before speaking of the table, I would like to say some word on Mendeleev. Dmitry Mendeleev is born in Siberia in 1834. He was the youngest of 17 children, but only 14 reached the age to be baptized. His mom always believed in him and pushed him to study. His father became blind and lost his job. Family moved to Moscow. He is accepted in the Institute of St. Petersburg, graduated in 1854. But he got the tuberculosis, went on the coast of Black Sea. He survives and came back on 1857 to St. Petersburg. He spent 2 years in Paris and 2 years in Heidelberg. He proposed the table in 1869. The atom can be ordered by the number of protons in the nucleus, starting from 1 up to 94 in the nature and 118 with the new elements we created. But several people started to see that some atoms had the same behavior as, for example, lithium, sodium or potassium. They think it makes sense to organize in table to get the same behavior in the same column. In 1863, 56 elements were known with a discovery rate of 1 new element by year. Several scientists were working on periodic table, but they fill all the cases of the table, while Mendeleev got the genius idea to keep some empty case, see red rectangle, because he thought that the element was not yet discovered. As for example, the element below the silicon, predicted in 1869 and called as silicon, and the element below aluminum, predicted in 1871 and called as aluminum. In 1871, Mendeleev predicted 2 other elements, the technetium, called as manganese, and the scandium, called as boron. Paul-Émile de Bois-Baudran isolated the gallium in 1875, so 4 years after the Mendeleev prediction. In 1879, the predicted scandium was discovered. Winkler, 2 decades later, isolated in 1886 a new element called the germanium for Germany. Maybe because he thought that de Bois-Baudran called gallium for gold, the Latin name of France. The technetium was isolated in 1937, which means 30 years after the death of Mendeleev. But at least over the 4 elements predicted by Mendeleev, 3 of them was discovered during his lifetime, showing that its hypothesis to let some empty cases was the right one. The choice of line and column was a smart choice because in 1869 they didn't know about the electron shell. But in fact, the first line represents the element with a single shell filled with 2 electrons for hydrogen and helium. The second line represents the element with 2 electron shell, the second one filled with 8 electrons. The third line have element with 3 electron shell, then the fourth line with 4 electron shell, and so on. This means that each line corresponds to an additional electron shell. Now, for each column, all elements have the same number of electrons in the last shell. Now we will focus more on the 2 elements used in solid-state electronics, at least at the beginning, with in the order germanium and silicon later. They started with germanium because it was much easier with a melting point of 940 degrees C compared with the silicon at 1414 degrees C. I also highlighted with a red rectangle the 7 elements around the germanium and silicon, which are part of the third and fifth column. All the elements in the column 4 have 4 electrons on the last shell. But if we take elements of the third and fifth column in same quantity, the average of the electron on the last shell will be also 4. So it behaves as an element of the fourth column as ASGA, initially used to build the lead, then gallium nitride. We can also use both elements of the fourth column as silicon carbide. I want to thank you for your attention. On my next Thierry Sicard tutorial number 40, we will talk about the atoms rules to build covalent link crystal or ionic crystal. So see you soon and stay tuned.